everybody. Today's practice problem comes from Economics, Principles and Applications, 6th edition, by Robert Hall and Mark Lieberman. We're going to be doing Chapter 5, problem number 12. The problem begins as follows. 3 guys named Al, a moving company, is contemplating a price hike. Currently, they charge $30 per hour, but Al, unclear which one, thinks they could get $40. Al, another one, disagrees, saying it will hurt the business. Al, the brains of the outfit, has calculated the price elasticity of demand for their moving services in the range from $30 to $40 and found it to be 0.5. Now, the first part of the question asks us to think about, based on revenue, not based directly on profit, should they do as Al suggests and raise the price? So we can think about what information we have and how we can use that to figure out whether this would be a good decision from a revenue perspective. So let's think about what we have here. They're saying they're contemplating a price change from $30 to $40. Okay. So what else do we know? We know that over this range, the price elasticity of demand, which is little e sub d, or sometimes big e sub d, was calculated to be 0.5. So we can think about what this proposed price change will likely do to total revenue. So there's a few things that we can notice here. First of all, because this elasticity of demand is 0.5, or probably if you didn't take the absolute value of it, it would have been negative 0.5, since price and quantity demanded move in different directions. We can categorize this as inelastic demand. We say that inelastic demand is demand where in magnitude it's less than 1, and elastic demand is demand where in magnitude it's greater than 1. And we could think about, we have rules that directly relate elasticity to whether or not you get increased revenue from a price increase. But let's actually work through it here rather than just saying, oh, based on this rule that you memorized, here's the answer. So what this means, let's ignore the midpoint method for the time being. Let's just go with the very basic elasticity formula. Is this means that 0.5 is equal to the magnitude of the percent change in quantity demanded divided by the percent change in price, right? So we could think about what's going to happen to our quantity demanded if we had a figure for percent change in price. But we do, because we said our price is going from $30 to $40. Well, we can see that that's an increase of $10 on a base of 30 for an increase of 1/3, or 33%, right? So we could say that this is going up by 33%. If you weren't comfortable doing that in your head, we could have said that the percent change in price is equal to the final price, which is 40, minus the initial price, which is 30, over 30, times 100%, which would just give us 10 over 30, or 1/3, times 100%, which would approximately be 33%. So what we can see here is that 0.5 is in fact equal to the absolute value of the percent change in quantity demanded divided by, well, we now know that the percent change in price is 33%. And what this must mean is that the absolute value, at least, of the percent change in quantity demanded, if we were to just multiply both sides by 33%, is just going to equal 0.5 times 33%. So we can think about, this is 33% divided by 2, which, if I'm doing my math correctly, is in fact 16.5%. So we can see here, we have two things. We have our price is going up by 33%, and we have our quantity demanded. Remember, because they move in opposite directions. So even though the absolute value of the percent change in quantity demanded is 16.5%, the actual quantity demanded is a negative change. So it's going to be down by 16.5%. Now, if we look at these numbers, what this is basically telling us is, well, you're losing 16.5% of your customers, or your units sold, to be more specific. But you're getting 33% more from each of those customers, or each of those units that are still getting sold. I don't know about you, but this sounds like a good trade-off, and it sounds like one that overall would give me more revenue. Because remember, total revenue is equal to price times quantity. So if you're increasing this guy by 33% and only decreasing this guy by 16.5%, we're going to see that our total revenue increases as a result of this price change. And in fact, we can say in general, when we have inelastic demands, we can think about what our rule is. And we don't have to actually memorize it, but we can generalize from this. We can say when we face inelastic demand, if we were to raise our price, we're going to raise our total revenue. That's just what you saw here. And in fact, the opposite is also true, that if we lowered our price, we would be lowering our total revenue. And you can think about why that would be the case. And that would be the case simply because if we were to do this in reverse, say we made the price go down by 33%, so we're getting 33% less from each unit that we're still selling, but we're only selling 16.5% more units, that's not going to make up for the difference. We're going to have less revenue than we were before. We could even do the opposite and think about, well, if we had elastic demand, what does this relationship look like? And not surprisingly, the relationship flips. So if we had elastic demand, or demand where the price elasticity is greater than 1 in magnitude, then if we were to raise the price, we would actually see total revenue go down. And conversely, if we were to lower the price, we would see total revenue go up. And you can think about why this is. If we had elastic demand, that might be a situation where if we increased our price by 10%, our quantity demanded decreased by 50%. That would give us an elasticity of 5. You say, well, then if I raise my price, I'm getting 10% more from each customer that I still have, but losing half of my customers. That doesn't seem to be a good trade-off, and that's going to lower my revenue. Conversely, if I were to put things on sale by 10% and get 50% more customers, that does seem like a good trade-off, and that price decrease would actually increase my total revenue. So we can see here, in response to this specific question, because we knew that our price elasticity of demand was less than 1, we were in inelastic territory. It didn't even really matter how big this price increase was, but we could say for sure that raising the price is actually going to increase our total revenue. If we wanted to, we could actually calculate this rather than rely on our intuition, and we could see why these numbers are going to give us an increase in total revenue. So we can think of that as follows. We could just go back to the point here where we said that total revenue is equal to price times quantity. And you could think about, well, the total revenue, the old total revenue, just call the old price P and the old price and the old quantity Q. Well, then if our price goes up by 33%, we could say our new total revenue is equal to P plus 33% of P, which algebraically is just 1.33 times P. And we'd be multiplying this by, well, now our quantity demanded is going down by 16.5%. So we'd say, well, what we're going to have as our new quantity is just Q minus 16.5% of Q. Or Q times 1 minus 0.165. And what that comes out to, think about it here, 100% minus 16.5%, if I'm doing my math correctly, is 83.5%. So this would just be 0.835 Q. And we could actually multiply this out to see whether we get something that's smaller than or bigger than this original P times Q. So I could just do that, and it just involves multiplying 1.33, so is it 1.33 times 0.835 is equal to 1.11055 times P times Q. Now we can conclude from this, because we know that P and Q are both greater than 0, that this new total revenue is going to be bigger than this old total revenue here. And this is just a more precise way of showing that when your elasticity is greater than 1 in magnitude, or when your percent decrease in quantity demanded is less than your percent increase in price, we're going to get a revenue number that's bigger than what we started with. Part B of the question says, currently, Three Guys is the only moving company in town. Al reads in the paper that several new movers are planning to set up shop there within the next year. 12 months from now, is the demand for Three Guys services likely to be more elastic, less elastic, or the same? Now we can think about the list of factors that affect price elasticity of demand in general, and we said that one of those factors was the availability of substitutes. So if we have these new competitors coming into the market, it's a pretty good bet that their services will be pretty close substitutes for the services of Three Guys Moving Company. So as we get more and more substitutes into the market, that correlates with more elastic demand, or more price sensitivity if you think about it. And that makes sense, because if consumers have more similar options that they can switch to, then it's easier for them to be price sensitive. And it's easier for them to run away and decrease their quantity demanded when they're facing a price increase. One last thing to note about this analysis. You'll notice that we were very careful to specify, assuming that we're looking at this and caring only about revenue, is the decision to move from a price point of $30 to a price point of $40 good for business. And we decided that in terms of revenue, it was a good idea given the numbers we saw. That doesn't always mean that it's a good idea in terms of profit, which is total revenue minus total cost, or how much you have left over at the end of the day, which is in reality what rational firms care about. So just keep in mind here that we have an interesting finding versus having to do with revenue, but revenue isn't the only thing that we care about or the end goal that most firms have when they're seeking profit instead.